Okay, so everyone can see my screen, hear my voice, right?
Yep.
Yep.
Cool. So before I dive into this, I didn't have as much statistics to guide me on this one. Do people have questions that they really want me to go over for the homework 2, the web work 2? No? Okay. Then in that case, I'm going to walk you guys through 1, 2, 6, and 8, which seem to be the problems that that people were having the most trouble with. So what do people think I'm going to do to start off on question number 1? So I've got this point P here, and I want to find the distance to the line that goes through both A and B.
You'd start by finding the vectors for AP and AB, right?
Yeah, exactly. So we get P minus A vector is going to be equal to, it's going to be 2, 3, 2. And then B minus A vector is going to be equal to, so that'll be 1, -1, -1. Cool. So what's my next step here?
Find the projection onto AB.
Yeah. So we're going to do the projection of AP onto AB. And what's the formula for that?
AP dot AB over the norm of both of them.
Is it so? Yeah. This, AP. I'm just going to call this vector AP and this guy AB. So you're saying this?
Yeah.
Well, I need to spit out a vector. So what else? I'm missing something else here. This is most of the way, but I also need the vector AB here itself, because this right here, this would just give me a number. But what I actually need is a vector that I'm going to get. So geometrically, what does this actually give me? Actually, so I think that the formula is going to be something slightly different. I think it's just going to
The bottom is supposed to be the norm of B, the AB squared.
Yeah, good.
I used the wrong formula.
Yeah, no, you're good. Okay. Thank you. So geometrically, we have, this is the picture that we have, and this basically is the new vector that it's giving us. It's just this thing up until this point. This isn't actually what I want, right? I want this vector right here. So what I'm going to do once I get this, if I call this vector P for projection, let's go PR, then what I want is AP minus PR, right? And that would be my final answer. So if I were to do this, what is the dot product of these two? So that would be 2 minus 3 minus 2. So the dot product up here, this would be minus 3. And then the AB squared. So that is actually just 3, right? Because we would have the square root of 1 plus 1 plus 1 all squared, because these guys are all squared, but no, 1 squared is 1. So that gives us -3 divided by 3 times this vector right here. And then what we would have is we would get the, that would tell us the projection. So that's actually saying that the projection is just -1 of this, which would mean that it's actually on the same line, just in the opposite direction. And then we would just do the subtraction here, and then we would find the norm, and that would give us our D. Does that make sense to people? Do you guys see that this D vector here is just going to be AP minus the projection?
Yeah.
Cool. Then that is the kind of main theoretical point. So question 2 here. So I want to find the 2 unit vectors that are orthogonal or to A and B. So how do I find a unit vector that is orthogonal to both A and B? So you guys have basically only learned 2 tricks recently, right? We just used dot products in the projection. What's your other trick that you guys have learned?
Cross product.
Yeah. So the cross product gives you something that is perpendicular to both of the things that you are cross producting. So if we get A cross B, it's going to be perpendicular to A, and it's also going to be perpendicular to B. Yeah. So this is, if we do this, we get I, J, K, and then, so it's going to be equal to the determinant of I, J, K time, or 4, 3, 4, 0, 3. So if we do this, then do people know how to do the determinant? So basically we do this top right, and then we pair it with this. So that gives us I times the determinant of that smaller square there, 3, 0, -3, minus, when we switch to the next one, when we move over, we do the, we switch signs every time we jump from one to the next. And then we basically block out whatever that column / row is in. And then we do the determinant of the things that are next to it. So we have this 4, -4 column, and this 3, -3 column here. So let's we get 4 j times 4 -4 3 -3 plus k times now we'll have this square here because we're blocking out this column now. So k times 4 -4 -5 0. So if we do that, then we get the determinant of this is -5 times -3 So that is positive 15i, and then, sorry, it's positive 15 plus 3 times, or sorry, minus 3 times 0, which is 0, obviously. So it's 15i, and then we get minus, if we do the same determinant here, we get 4 times negative 3 is negative 12, minus 3 times negative 4 is 0, and it's only going to be 0 if these two columns are scalar multiples of each other, which they are here. So we get minus 0j plus 4 times 0 is 0, minus 5 times negative 4 is going to be triple negative is negative 20k. So we can rewrite that as 15, 0, negative 20. And so what do I have now? Is that my answer?
No, you got to find the unit vector of that.
Yes. So I have to divide it by its norm. So what is, or by its magnitude. So what is its magnitude? So that's 15 squared plus 20 squared square rooted. So I can pull out a 5 from both of these guys. So this is actually the same thing as 5 times 3 squared plus 4 squared. And this right here is also 5. So this guy right here becomes, if I divide by 25, then this becomes what? That's 3 over 5, 0, negative 4 over 5. How do I get the second one?
Is it just the same thing or no?
I just multiply it by negative 1.
No, okay.
Right, to get the other vector that's orthogonal and length 1 in the opposite direction, I just multiply by negative 1. So negative 3 over 5, 0, and positive 4 over 5. And if I had done B cross A instead of A cross B, this is what I would have gotten. So basically, if you switch these guys, if you switch the two rows there, then it just gives you the negative of what you would have gotten. Okay. Any questions on that? Cool. So this one, I also wanted to just point out so if we were to, we want to find the area of this parallelogram, then we would want to draw the picture of this, and then we would want to pick 2 of the adjacent vertices. So basically, if I can't pick these 2 opposite ends or these 2 opposite ends, I can pick this guy and then its 2 adjacent vertices to define my vectors. And then I can use, if this guy is A and this guy is B, then A cross B, that area is going to be equal to the area of the parallelogram. And one of the questions that comes up pretty often is usually not find the area of the parallelogram. Like it's in your homework 1.4 PDF, and I've seen it on exams several times before. It's not usually that, but it's find the area of this triangle. And that's going to be the same thing. You get A and B as your vectors, but then you can extend this triangle, kind of do a mirror image of it, and then this would give you a parallelogram, and you'll find that the area of the triangle is going to be equal to the A cross B, the magnitude of A cross B divided by 2. Does that make sense? That's something that comes up that it's worth knowing. And then you can, okay, yeah. So if in this question right here, 4 here, if it were to say to compute the area of this triangle with vertices, then you would pick, so this is A, this is B, this is C. If you were to do this, then you would do the vector A minus, or AB cross the vector AC, and then you would do the norm of that, and that would give you the area of this parallelogram. So if you want the area of the triangle instead, which is just half the size of that parallelogram, we divide by 2. Cool. Yeah, so this, you can just use this. This question is just the magnitude of V cross W is going to be equal to V, the magnitude of V times the magnitude of W times the sine of the angle between them. And then the dot product is going to be equal to the magnitude of W, magnitude of V times the cosine of the angle between them. So that is how this kind of relates very intimately into trigonometry. But this guy, so I want to first off find the line that passes, or the line that's parallel to this that passes through that point. How am I going to do that? So I want the line that is parallel to this guy that passes through this point. So there's a general form for lines that are parallel to this one, right? It means that they have to have the same slope, and their slope for these guys is just that coefficient that's attached to t, right? But then it can be off by a constant. So what I have for the general form for anything that's parallel to this is going to be x is equal to x naught plus 7t. Y is going to be equal to y naught plus 7t, and z is going to be equal to z naught plus 5t. So if that's the case, how do I use this to figure out what it is? What would the slope of this line, or what would the formula for this line be?
I'm not positive, but could you make like the numbers in P like equal to x naught, y naught, and z naught? And
That's exactly right. Because that's what I get. What happens when I set t equal to 0? Then I get the point of this line is just going to be x naught, y naught, z naught. So I can guarantee that this goes through that point if I just pick these values to be my x naught, y naught, and z naught. So I get x is equal to 5 plus 7t. Y is equal to 3 plus 7t. And z is going to be equal to -5 plus 5t. Right? So now I want to find where it intersects these 3 planes. what defines the XY plane? What is the equation that would give me the XY plane? So if I were to try to draw the XY plane in 3D space, I will try to make this enlightening. So if this is X, this is Y, and this is Z, and the XY plane would go something like this, right? Cover something that looks like that. Sorry if my artistic endeavors are not terribly informative. So the XY plane is when Z is equal to 0. That is what defines the XY plane. So if I have that, what am I going to do? How am I going to find the point of intersection? I just plug that in. I plug Z equals into 0 into it, and that gives me a t value. I use the t value to find my point. So if t is equal to 0, or z is equal to 0 is equal to -5 plus 5t, that's going to tell me that t is equal to 1. And I can plug that into these guys, and I get 12, 10, and 0, right? 5 plus 7 times 1 is 12. 3 plus 7 times 1 is 10, and z is obviously going to be equal to 0. Does that make sense to everyone?
Yep.
Cool. From here on out, it's going to be basically the same thing. The xz plane is where y is equal to 0, and that gives us, so if we have 3 plus 7, t is equal to 0, then that tells us that t is equal to -3 over 7. When we do that, we get 5 minus 3 is going to be equal to 2, 0, and then we get -5 plus, minus 15 over 7, which is also -50 over 7, if you prefer to write it like that. Same deal here, but we get, for this guy, we have x is equal to 0, and then that gives us t is equal to -5 over 7. We get 0, -2 here, and then this becomes -5 plus 35 over 7, minus 35 over 7, and that is -70. Yeah, that would be -70 over 7. Yeah, so -10 there. Am I calculating that right? So this would be -25 over 7, and then that would give us -60 over 7. That's it. Does that make sense to everyone? Cool. So this guy, have you guys covered the normal of a plane yet? No? Okay. Well, basically, so if we have a plane, and we've got this point on it, and then we've got this thing that's perpendicular to it, this vector that's perpendicular to this plane at this point. So we have, so it turns out very, very nicely that the vector that is going to, that the normal to this plane, the vector that's perpendicular to this plane is going to have basically the same coefficients. So what we'll have is we'll have something that looks like 3 times x minus x naught plus 5 times y minus y naught plus z times, plus 4 times z minus z naught is going to be equal to some c, and usually we're going to have it be 0, and then it's going to be absorbed into one of these for our starting point. So we'll set that equal to 0, and this forms the equation of a plane that is perpendicular to this vector. So how do I make it perpendicular to the vector at this point? How do I make it perpendicular to the vector? How do I pick a plane that is perpendicular to that vector at that point? Guys, we basically did this trick already. Yes, exactly. Thank you, Josephine. So I just plug in 3 times x minus -2 plus 5 times y minus -1 plus 4 times z minus 3. And then this is where I have to have it equal to 0 to make this work. This is basically fine. I would suggest, just for the sake of simplicity, writing it like this. Times z minus 3 is equal to 0. But if you want, you can also distribute this out, and then you get 3x plus 6 plus 5y plus 5 plus 4z minus 12 is equal to 0. 6 plus 5 is 11, minus 12 is -1. And then if I move the -1 over to the other side, it becomes positive. So this is the same thing, saying 3x plus 5y plus 4z is equal to 1. This is the cleanest way to write it, but either of these is also a perfectly acceptable answer for you to put. Cool?
So we're not actually going to put like equals c. We're going to have to write 3x plus 5y. So it's supposed to be in a format like that.
Yeah, you'd have to have it equal to 0, and then all of these guys be actual numbers. Otherwise, what you have is some plane that is parallel to it. So if I change the c, if I have like 12 instead of 0, I get a plane that is parallel to this plane, but I want a plane that goes through this point. Does that make sense?
Okay. I think so. I think I'm following along. I'm trying to do it right now by myself. If I have trouble, I'll message you.
Okay, cool. Anyone have any other questions? So that was the last one that I was planning on going over. So if no one has any other questions from this homework, then or from either of these other homeworks, or what you covered in class, then you are free to go.
Thank you. Have a nice day.
Thank you.
Thank you.
Thank you.
Have a good one. O'Day, are you just working on this problem right now?
Yeah, right now. So mine was a bit different. Instead of mine being all pluses, it's all negative.
Oh,
So I'm right now trying to do that. But right now I'm on the second part where I'm distributing